In this video, we're going to discuss how you can write exponential functions when you're given either a word problem, a table, or a graph. We're going to start with some examples about word problems, then we'll do table, and then graph. When you have any exponential function, all exponential growth functions are in the form a is equal to p times 1 plus r to the t, where a is the amount after t amount of time. P is the principal amount. Principal means original. Let's say somebody invests $30. Their principal amount, their original amount they invested is $30. R is the rate of growth as a decimal. And T is the amount of time. Exponential decay functions are in the form A is equal to P times 1 minus R to the t, where again a is the amount, p is the principal amount or the original, r is the rate as a decimal, and t is the time. So let's say we had something with exponential growth. Bacteria is growing over time. Let's say we want to solve it for the amount. We would plug in for the principal amount. Let's say we started with 30 bacteria, and our rate is that it's growing by 50%. So then we're going to convert 50% to a decimal, and that's 0.5. So we're going to have 1 plus 0.5 to the t, let's say it's over 10 years, we're going to plug in a 10 by t. Let's say we have exponential decay, we have bacteria, and the population of bacteria is dying out. We want to solve for the amount after 10 years. So the principal amount, let's say we start with 30 bacteria. Our rate is that they're dying out by 2%. That means 2% as a decimal is 0.02. So we would have 1 minus 0.02 to the t, which is 10. Let's look at some actual Regent questions about writing exponential functions from word problems. This is question number 12 from the June 2017 Algebra 1 Regent. Anne invested $1,000 in an account with a 1.3% annual interest rate. She made no deposits or withdrawals on the account for 2 years. If interest was compounded annually, which equation represents the balance of the account after the 2 years? So this is exponential growth because she's gaining money. She's getting more money each year because she's collecting interest. And all exponential growth functions are in the form a is equal to p times 1 plus r to the t. A is the amount after 2 years. P is the principal or the original amount. R is the rate as decimal. And t is the amount of time. So here we're going to plug in whatever we can to solve for a, which is the amount. A is equal to p. The principal, the original amount that she invested, is $1,000. Times 1 plus the rate. Now this is tricky because it looks like it's already a decimal, 1.3%, but we don't want to have this percent symbol. To get rid of the percent symbol, we have to convert it to a real decimal by moving the decimal place 2 places to the left, and we're left with 0.013. So 1.3% is equal to 0.013, and we're going to plug that in. To the t, the amount of time they tell us is 2 years. And they don't even want us to solve the equation in this question. If we needed to solve it, we would just solve out this whole thing. We could do it on the calculator, but we don't even need to do that for this question because the answer is choice 2, which exactly matches the equation we just wrote. Let's look at another question. This is question number 26 from the August 2014 Algebra 1 Regent. Rhonda deposited $3,000 in an account in the American National Bank, earning 4.2% interest, compounded annually. She made no deposits or withdrawals. Write an equation that can be used to find B, her account balance after t years. So this represents exponential growth because she's earning interest. All exponential growth functions are in the form a is equal to p times 1 plus r to the t. A is the amount after 2 years, p is the principal or the original amount, r is the rate as decimal, and t is the time. We're going to plug in whatever we know here to solve for her balance. We know that a, the amount, we're representing that by b, which is the balance. P, the principal or the original amount that she deposited, was $3,000. Times 1 plus the rate. The rate is tricky because it looks like it's already a decimal, but notice the percent sign. We have to take away that percent sign by moving the decimal place 2 places to the left, and we're left with 0.042. Raised to the t, and they don't tell us what t is, so we just want to write the equation. We don't even want to solve it. Now this could be your answer. You could write this as your answer, put a box around it, circle it. This could be your answer, and you would get the answer right. Or you could simplify it a little more. You don't have to, but you can simplify this to 1.042 to the t. We just added 1 plus 0.042 and raise that to the t. What you cannot do is multiply 3,000 by 1.042 because you have to realize that they are not like terms, because this term has a t as an exponent and this one has either no exponent or just a 1 as an exponent. Now let's look at how you can write an equation for an exponential function if you're given a table of values, not a word problem. This is question number 36 from the June 2015 Algebra 1 Regent. An application developer released a new app to be downloaded. The table below gives the number of downloads for the first 4 weeks after the launch of the app. And then we have a table. Write an exponential equation that models these data. This question actually does have 2 more parts to it. We aren't going to discuss them in this video because they're not related to the topic of writing exponential functions. In order to answer this question, we need to somehow write an equation using these points 1, 120, 2, 180, 3, 270, and 4, 405. We can do it very easily. The easiest way to do it is by doing it on the calculator. If you press the Stat button and then go into Edit, press Enter. Here is somewhere where you can write lists. What we're going to do is we're going to put in L1. We're going to put in all our x values, or the number of weeks, 1, 2, 3, and 4. And in L2, we're going to put in their corresponding y values, or the number of downloads, 120, 180, 270, and 405. So let's do that. 1, 2, 3, 4. Then the next column, 120, 180, 270, and 405. And now if you want, you can graph this to see how it looks. Let's do it. It's not really necessary for answering the question, but let's do it anyways. If you press the second button, you notice it's blue when it's not clicked. And then if you click any button, you're really clicking on the little blue words above the button. So if we press y equals, we're in the stat plot menu. And by plot 1, notice it says off. So press enter, we want to turn it on. Now the cursor is on, press enter. And our x list is L1, that's true. Our y list is L2. And we're making a scatter plot because we have points. So far it's all good. And now we're going to press zoom 9. Zoom 9, if you scroll down, you see it's zoom stat, and we're in the stat menu. This is really for statistics, but we can use it for this also. So we're going to do zoom 9. Notice that it kind of looks like an exponential function, but what we need to do is write an equation that connects these points. To do that, we're going to press Stat again, and we're going to scroll the right arrow to Calc, and we're going to scroll down until 0. EXPREG stands for exponential regression. We're making an exponential curve that passes through those points. Press Enter. And the X list, we already made it to be L1, and the Y list is L2. That's all correct. We don't have a frequency list. We're not going to discuss that now. Store regression equation. If we wanted to graph this equation on the graph, we could store it in either Y1, Y2. Let's store it in Y1. So to do that, we're going to press alpha and then click on the trace button for F4. And here we could choose, do we want Y1, Y2, Y3, Y4, Y5? Let's do Y1, press enter, and scroll down to calculate and press enter. The calculator just calculated for us our equation. They tell us y is equal to a times b to the x, and they give us values for a and values for b. They tell us y is equal to a is 80 times b is 1.5 to the x. And this is our equation. It's a bunch of steps to do it on the calculator, but it's very easy. All you have to do is punch in those numbers, press a few buttons, the calculator will give you your equation. Let's see how it looks when it graphs. Notice how the line passes through the points perfectly, because that is the equation of the line that passes through those points. Let's do another question. We're going to do one where we're given a graph and we have to write an equation for the exponential graph. This is question number 32 from the January 2015 Algebra 1 Regent. Write an exponential equation for the graph shown below. And then we have a graph. The easiest way to do this is by doing it on the calculator. If we find x and y coordinates, we can plug our x coordinates into L1 on the calculator, and our y coordinates into L2, and have the calculator calculate for us an exponential regression equation. So let's look at our x and y coordinates. The first one that we can see easily is over here at 2, 1. So our x value is 2, our y value is 1. Next one is 3, 2. So L1 we're going to plug in 3 and L2 is 2. Next, by x is equal to 4, we have y is also equal to 4. So we have 4, 4. Next, at x is equal to 5, y is equal to 8. So we have 5, 8. And those are all the points we could find. Now let's go to the calculator. We're going to press Stat, Edit. In L1, we're going to plug in 2, 3, 4, 5. So 2, enter, 3, enter, 4, enter, 5, enter. And then by L2, we're going to plug in our y values 1, 2, 4, 8. 1, 2, 4, 8. And we're going to press the Stat button again. Right arrow to Calc for Calculate. I'm going to scroll down to 0 for exponential regression and press Enter. Our X list is L1, our Y list is L2, that's correct. We don't have a frequency list, we're not going to discuss that now. We're not going to store this regression equation, we don't really care to see how it's graphed, we already know how it's graphed, we have the graph next to us. So we're just going to scroll down to Calculate and press Enter. And the calculator calculated for us, Y is equal to A times B to the X, and A they tell us is 0.25 times B, which is 2 to the X, and this is our equation. The next part of the question says explain how you determine the equation, and you can write just what we did. We stored the X coordinates as in L1, the Y coordinates in L2, and we use the calculator to calculate for us an exponential regression equation.